Hi guys, how's it going? I hope you guys are productive and healthy during quarantine. Man, it's crazy stuff. But okay, let's begin. So, we're going to go over five different categories of material properties. The first one being physical properties. Um, Following this is mechanical properties, thermal properties, electric magnetic properties, and optical properties. Okay? So, um, I have translated the word for you. So, if you don't understand what I'm saying, hopefully you can gain some context clues. Okay. So, mechanic resistance is the ability of a material to resist a force without breaking, right? So, for example, glass is relatively fragile and it doesn't take much to break it, right? As opposed to maybe a brick, right? You couldn't punch a brick. I mean, some people can, but you can't punch a brick and break it, right? So, mechanic resistance is the ability of a material to resist force without breaking. Toughness. Toughness is a material's resistance to breaking, right? For example, metals are relatively tough. Glass and porcelain are fragile, right? You can break porcelain very easily. And another example I have here with toughness is a diamond, because diamond is like the toughest material out there. Next, we have plasticity, right? So, plasticity is the ability of materials to keep their original shape once they have been deformed. For example, silly putty or maybe clay, right? You can mold it into any shape you'd like, but afterwards, you can mold it back to its original shape. Next, elasticity is a material's ability to change its shape when a force is applied to it and recovers its original shape when force disappears. Perfect example, a balloon, right? When you blow into a balloon, the force makes the balloon or the rubber expand, right? And once the force disappears, it goes back to its original shape. Now we have malleability, right? This is a material's ability to be squeezed into a new shape of sheets when compression or force is applied to it, right? Malleability. We use this word a lot with metal, right? Because metal can change its form often, right? If you find a raw piece of gold and apply heat to it, you can form it into money. You can form it into gold blocks. However, it's hard to get it back to its original shape, right? Ductility. Ductility is the ability of a material to be stretched into new shape of threads when compression is forced and applied to it, right? Thin material intertwined, right, to make a thicker material. It's ductility. It's very flexible, right? The wires here that you see in um, cords, right? They're ductile. They're flexible. They can be wrapped, right? And typically they're quite conductive. Okay, moving on to the next, right? Thermal properties. Next, right? And a property of a thermal material would be expansion, is the ability to increase volume, right? So think about water, for example. The hotter it gets, the larger it gets. Fusibility, right, is a material's ability to be reduced in volume, right? So with metal, you can heat it up and you can take bits and pieces of metals, right? You can reduce its size, right? By using heat, right? That's why it's thermal. Thermal property would be fusibility. Another property of would be contraction. Contraction is the ability of a material to reduce its volume, right? So if you apply heat to metal, right, for too long, it will shrink, right? It will reduce its size. If you look at A, you can see that there's a line in the middle, right? And that has to do with, you know, this material is being soldered, but it's being fused together. It's being contracted together. How would I explain this? Okay. Contraction is the ability of material to reduce its volume. So, exactly what I said is if you apply too much heat to it, sometimes this material can shrink. Moving on. Okay, electric magnetic properties. The first one would be electric conductivity, is the ability of material to let electricity flow easily, right? Metal is typically really conductive, right? There's a lot of electrical conductivity within metal. It's a little different with porcelain, right? Not the same. Ferromagnetism, right? This is the ability to attract other metals, right? So in this picture, you can see the magnetic uh, directions, right? You have um, where where the magnetic pull is forcing, where it's directing to. So, for example, on the right side, it says absence of magnetic field, right? All of the ions are going in the same direction, okay, which is away from each other. And then if you go to the left, you have the presence of the magnetic field, which some of the ions are going every which way, but they're kind of attracting one another, right? So ferromagnetism, the ability of materials to attract. Okay, optical properties. So these are things that we can see, right? We're probably familiar with this. So opaque is the ability for materials to repel light, right? So no light travels through opaque materials, right? Opaque. My glass mug, opaque. No light is going to travel through it. Next would be transparent, right? All light travels through them and you can see what's behind the materials, right? Transparent, right? Totally transparent, right? The far right. So light can go through it. For example, like this, right? The glass, totally transparent. Pretty flowers. Okay. Translucent. Some light can travel through, but you cannot see what's behind, right? So that's going to be in the middle here. Some light can travel through, but you won't be able to see what's behind it. Okay? Okay. Chemical properties. So now we're on to chapter 2. Okay, chemical properties. Number 1 being oxidation. Oxidation is the change that occurs when metal is exposed to water and air, right? And oxidation creates iron, right? So that orange material has been oxidized and now is turned to iron, which on the periodic table is Fe. ecological properties, biodegradable, toxicity, and renewable. Ecological properties, biodegradable, materials that decompose naturally with time. For example, an apple takes about 20 days to decompose. Plastic takes 10 years, and glass about 400 years, right? That's a big difference. So your vegetables, your organics, right? They're biodegradable, right? Some different types of toothbrush, biodegradable because it's wood, right? But if you take glass, it's going to take many, many, many years. It's not very biodegradable. And plastic, up to 10 years. I mean, I'm sure you can make biodegradable plastic, but it's not very common. Cool. Toxicity, right? Materials that are harmful to the environment because they contaminate water and atmosphere in the atmosphere. So let's think of some toxic materials, right? One being gasoline. We use it often. We need it to drive our cars. We need gasoline, but it's toxic. And if it is exposed to water, it could kill lots of different ecosystems, aquatic ecosystems, and it's potentially dangerous, very dangerous. And also think about the atmosphere, right? Carbon into the air. Thanks a lot. Okay. Renewable. It can be replaced or replenished in the same or less amount of time than it takes to draw the supply down, right? So here are some examples of some uh, renewable materials, right? Energy, solar energy, wind power, right? Geothermal energy. Pretty cool. Acoustic properties, acoustic conductivity. Acoustic conductivity is how materials behave with sound, right? So think about metal. Think about the strings, the ductility of the strings, right? How does it make noise? Can you hear it, right? So acoustic conductivity is the sound of different types of materials, right? The way glass sounds is much different than the way metal sounds, right? That's why instruments are made out of metal and not out of glass. I don't have coronavirus. Okay. Other properties. Um, Permeability and porosity, which go hand in hand. So, porosity is the ability to absorb or repel. No, the ability to. Porosity is the ability of a material to absorb liquid or gas, right? So, this picture is an image of cement, which is porous, right? It's porous. So there's holes inside. There's there's Okay, let me start over. Okay. So, porosity is the ability of material to absorb a liquid or gas, right? So cement, for example, is porous, right? There's spaces between the grains or between the rocks that allow water or gas to seep through. Aesthetic properties, texture, brightness, color, and smell. Aesthetic properties, texture, right, is a material's ability to feel to feel and to look different, right? So if you take a look at the pebbles, right, or rocks or stones on the top, the texture is going to be much different than the cement on the bottom. Texture. Brightness, right, is the abilities of material to reflect light. So we have brightness the closer to white or the closest to black, right? So what's the material's ability to reflect light? Color is the property possessed by an object of producing different sensations on an eye as a result of the way it reflects and emanates light, right? Color. We know this, we see it all the time. Here's an image of a color wheel, right? Smell, right? Is the ability of a material to emulate an odor or scent of a specific kind, right? So some materials, like you shouldn't smell, right? Like some woods have a nice woody, earthy scent to it. But other things, some materials like asbestos, like you cannot breathe that in. It's dangerous, you know? It's quite dangerous. Okay, guys. Well, that's all I have for you today. I hope that helped you understand the different types of properties in English. Okay. Feel free to reach out to me if you need any help. I'm around. Thanks. Bye.